You ever been out somewhere really dark, maybe in the countryside, and just seen fireflies? It's just this magical sight, right? Hundreds of these little tiny lights just dancing around. And it's those simple things that can spark a whole universe of questions. Like, where's that light even coming from? How does it get from them to my eyes? And what about all the other lights we see up in the night sky?
And this is a question I think a lot of us have had at some point. I mean, you look up, you see the moon shining so bright, it really does feel like this giant lamp someone hung up there for us. But is it? Is it really making its own light? Or is something else going on? Let's figure it out.
All right, so to really crack this moonlight mystery, we've got to start with the most basic question of all. Where does light come from? Turns out, everything you see, every single object, fits into one of two pretty simple boxes.
So on one hand, you've got your luminous objects. These are the universe's own light creators. The sun, of course, all those distant stars, and yeah, those fireflies from before. They're all making their own light. But then, you have the non-luminous objects. You can almost call them the great pretenders of the universe, because they don't make any light themselves. And the moon? Yep, it's the most famous one on that list. That beautiful, brilliant moonlight is actually just sunlight bouncing off the moon's surface. So the moon isn't a lamp. It's a mirror.
Okay, so now we know where light comes from, but what about how it travels? This next idea is so simple, but I promise you it is the master key. It unlocks literally everything else we're about to talk about, from the darkest shadow to the brightest reflection.
So how does it move? Does it curve around things? Does it zigzag? Or is it a lot more direct? Well, there's this really clever little experiment that shows us the answer, plain as day.
Okay, picture this. You take 3 matchboxes and you punch a tiny hole in the exact same spot on each one. You line them up perfectly straight. Then you take a little torch and you shine it right through that first hole. As long as that path is clear, what happens? Whoosh! That light zips straight through all 3 holes and bam! Hits a screen on the other side. A perfect little spot of light.
But now, watch this. The second we break that perfectly straight path, just nudge that middle matchbox over a tiny bit and nothing. The light hits the side of the box and just stops, dead in its tracks. And that right there, that shows us the fundamental rule. Light always travels in a straight line. That one little rule governs everything that's coming next.
So if light is so stubborn about traveling in a straight line, what happens when something solid gets right in its way? You already know the answer. You've seen it 1,000 times today. You make a shadow.
But you've probably noticed that not all shadows look the same. And that's because not all objects block light in the same way. You've got your opaque objects, right? Like a book or your hand. They stop the light completely, and that gives you a really dark, crisp shadow. Then you have translucent objects. Think like wax paper or frosted glass. They let some of the light sneak through, which is why their shadows are so much lighter, kind of fuzzy. And finally, transparent stuff, like a clear window. It lets almost all the light pass right through, which is why it barely casts a shadow at all.
So the recipe for making a shadow is actually incredibly simple. You only need 3 ingredients. First, a light source. Second, something opaque to get in its way. And third, a screen for that shadow to fall onto. And you know, that screen can be just about anything. A wall, a piece of paper, or even just the ground under your feet.
And of course, being human, we didn't just understand this science, we turned it into art. For centuries, people have used shadow puppetry to tell these incredible stories and share their culture, all just by mastering the simple act of blocking light in really creative ways.
Okay, so we know what happens when light gets blocked. But what happens when it hits a surface that doesn't block it, but instead sends it flying off in a whole new direction? Now this is where things start to get really cool.
This is called reflection, and really all it is light bouncing. Think of a ball bouncing off a wall. A really smooth, shiny surface, like a mirror, is perfect at this. It takes that straight line of light and just redirects it in another perfectly predictable straight line. But mirrors have this famous little trick they play on us. Go ahead and try it. Stand in front of a mirror, raise your left arm. Now look at your reflection. It looks like it's raising its right arm. It's so weird. This left-right swap has a fancy name. It's called lateral inversion. And it happens every single time light bounces off a flat mirror.
Now, keeping that weird mirror swap in your head, have you ever been driving and noticed this? The word ambulance, written completely backwards on the front of the vehicle? It looks like a huge typo, right? But it's actually an incredibly clever and even life-saving piece of science.
And there it is. That's the aha moment. A driver in front, when they glance at their rearview mirror, which is doing that same lateral inversion trick, sees the word flipped back the correct way. They can instantly read ambulance and know they need to get out of the way. It's a real-world, life-saving application of a simple rule of light. So cool.
So once you understand these simple rules, that light travels straight and that it bounces in predictable ways, you can start to manipulate them. You can basically start to hack your own vision to see things you otherwise couldn't.
Take something like a periscope. It feels like magic, doesn't it? The idea that you can see over a wall or see above the water from inside a submarine. But it's not magic. It's just a clever use of two mirrors. Light comes in from the world above, hits that top mirror, and bounces straight down the tube. Then it hits the bottom mirror and bounces directly into your eye. You're just bending your line of sight using a couple of reflections.
And if two mirrors can let you see around corners, what can you do with three? Well, you can build a kaleidoscope. By arranging three mirrors in a tube, you create this incredible engine for reflection. It takes simple little bits of colored glass and turns them into these infinite, complex, beautiful patterns. It's just the perfect reminder that a few simple, unbreakable rules of light can create endless complexity and beauty. It really makes you wonder, what else is out there to see if we just learn how to look?